Now, the important thing to understand here is that we can't just manufacture parts and guess at what type of tolerances we need to put onto these parts, right? We need something to follow. And as already mentioned, the RC, or the running and sliding fits, we can look at a table, we can look at charts, and it will give us the information that we need to manufacture these mating parts. But they're based on, there's two systems, and we're only going to talk about one today, okay? So there's two systems. There's the basic hole system and the basic shaft system. We're going to talk about the basic hole system. Now, the basic hole system, it's recommended for general use. I don't want to say that if you're not told otherwise, then just assume you're working off the basic hole system. If you're not sure, it's good to ask. But generally speaking, when an RC callouts are made on a print, they are going to be based off the basic hole system. So what this means is it's the hole that the basic size is referring to, and it's from the hole that the fits or the tolerances are sorted out. So the basic size is the design size for the hole. So if I said, I want you to manufacture this RC2, and it's a 1.25 diameter RC2 fit. Well, that 1.25 diameter, it's talking about the hole, not the shaft. That's what the basic hole system is. So that nominal size that you're given is referring to the hole, okay? So let's go through an example. So let's imagine for a second that you're given a print, and the print calls out a 1-inch diameter RC7. So it's pointing at the hole and the shaft, right? They're together, they're assembled. It's telling you that that fit that's required is a 1-inch RC7. Well, what does that mean? Well, if we're using the basic hole system, then what we understand is that the hole is 1 inch. That's what we understand from the basic hole system. And we can take the other dimensions from that, or the tolerances. So to kind of understand more about this, we actually need to look at a chart now. Like okay, so I know that this is the basic hole system. I know that that means that we're working from the nominal size of the hole being 1 inch. Well, now what? Well, let's call up a chart. This is just a chart out of a textbook. So this chart is an example of what you may see when you're trying to figure out how to manufacture the hole in the shaft. So what you know right now is you know that it's a 1-inch RC7. That's all you know. But what you gather from that is, being the basic hole system, that the 1 inch applies to the hole itself. So notice the highlighted line on this table. I've highlighted it so it draws your eye to it. The 1-inch diameter is between the 0.71 and the 1.9. So see this here? These are the nominal size ranges. So basically, if you want to apply like an RC6, 7, 8, or 9, it doesn't have the tolerance is called out for every possible size. You don't see here 0.7100 and then here 0.7101 and then 0.7102. It gives you a range, okay? So basically, if you have to manufacture any one of these fits, RC6 through 9, and the nominal size in the basic hole system is 0.71 to 1.19, then you're going to look at this line. So ours is a 1 inch, so we fall between the 0.71 and 1.19. So let's look across here, follow the row along to the RC7 column right here. And where they meet, the information that we need is right here, right? So where the row and the column meet, that's what we're looking for. So what we what's important for us when we look at a table like this is we have to make sure that we're interpreting the information properly. If you didn't know any better, you may look at that and say, how can there be a tolerance of 2 inches? Right? That might be the first thing you think of. It's 2.00. And you know what? If you don't have any knowledge or experience, or you don't have any information telling you otherwise, why would you think it's anything but plus 2 inch tolerance? I mean, over here, does this not say nominal size range in inches? 0.71 inches to 1.19 inches? Well, that's true. But what you need to know about all of the information beyond this, so outside of this over and to column, everything else over here, the decimal has been moved. And this large number that you see, this whole number, that is thousandths of an inch, okay? It's thousandths of an inch. So that whole number represents in this case, the positive tolerance of the hole in thousandths of an inch. So we've already determined that the hole diameter is 1 inch. And if we follow this row across and then down from the class RC7, we see that it's +2. Well, that +2 means that the hole is allowed to be 2/1000ths of an inch bigger than the nominal hole size of 1 inch. But it is a unilateral tolerance. We've talked about unilateral tolerances. This is one. Notice there is no negative limit, okay? So now what we need to determine is, well, what is this 2.5? Well, this is the minimum clearance. So remember, we're talking about fits, right? So even though this is called the basic hole system, it's the basic hole system is helping us to realize that this nominal size 1 inch applies to the hole. The tolerances are going to apply to both the hole and the shaft. So the minimum clearance is 0.0025. That's the amount of space that there has to be between the hole and the shaft. It is the bare minimum clearance that there has to be between the hole and the shaft. So that means that the shaft at its maximum size is going to equal the basic size minus 2.5 thou, right? That only makes sense. If the hole is 1 inch and it has a plus tolerance and no negative, and the minimum clearance is 2 thou 5/10, well, then that means that when that shaft is made at its maximum size and the hole is made at its smallest size, there has to be 2 thou 5/10 clearance. So that's how we figure out what the maximum size of the shaft is. We take the 1 inch and we subtract the minimum clearance, right? So therefore, this shaft cannot be any bigger than 0.9975. Okay, that is the maximum size that you can manufacture that shaft. Now, this last column here, that's the shaft tolerance. Notice we're looking here, we're talking about the basic hole system, but this is hole tolerance, and this is shaft tolerance. So we applied the hole tolerance. It's a positive value. We applied it as a plus right here. And it's unilateral, so there's no negative. Notice the shaft tolerance is negative 1 thou 2/10. So we apply a negative 1 thou 2/10 lower limit to the shaft tolerance here. But it's unilateral as well. Notice there it's a 0 here.